Okay, we ready to go? Yeah, like Ben said, I'm talking about computer networking, just the basics. So, advanced. I'll use the spacebar. So yeah, we'll just talk about the basics. So what an IP address, subnet mask, DNS, default gateways. So what's all that sort of stuff mean? I guess the first thing when it comes to IP addressing, it'll ask for whether you're using DHCP or a static IP. So DHCP means it's going to be automatic, usually comes out of your router, whereas the static IP is the process of manually encoding the IP address into your devices. And that's something that we want to do when we've got controllers, because we want to set the IP on it and know what it's programmed as, and we don't want to have it decide to randomly change midway through. But probably the most important thing is keep documentation and write the IP addresses on absolutely everything. Because you'll think you know what it is, but then you'll put it away and you come back to it and it'll just cause headaches. So what's an IP address? It's basically a number dot number dot number dot number. So it'll be something like 192.168.0.1. So each one of those numbers is going to be between 0 and 255. So for private networks, they always begin with 192.168 something something or 10 dot something something, or you can get more complicated with 172.16, but we won't worry about that. If you start seeing 169.254 something dot something, that means it hasn't worked. So if DHCP fails, that's the address that's going to appear. And again, there's much more to it, but we'll be here all day otherwise. The thing worked that time. So, important thing with IP addresses, they're like phone numbers. You can't have a duplicate. So, if our router's 192.168.1.1 and our computer's 1.5, we can't then give our controller the same IP as our computer. What will happen is one device will work and it's sort of picked at random, although it might work and then it might not work, so you get all sorts of weird stuff. Subnet mask is, for our context, is 255.255.255.0 and just enter that. It's actually a binary bit mask pattern to define the size of a network, so we'll very quickly touch on this. 255.255 in binary is all ones, so then that turns into a masking pattern to define the network size. If we change that the third 255 to 254, we've then got another binary 0, which then means we can have up to 510 devices. For what we're doing completely irrelevant. So moral of the story for Christmas lights, that's the magic number. So default gateway, that's going to be the router on your network. It's basically to say how to get out of the local subnet. So if your computer wants to talk to the internet, obviously the google.com's not on your network, so it's going to go to your default gateway, then the default gateway will then talk to another router and off onto the internet. If your controllers are only talking on the same network to other, say, 192.168 something devices, then the default gateway is not actually required. So DNS, that is used to convert your www addresses into IP addresses. It's only needed to resolve the names. So for controllers that don't connect to the internet, they probably won't need that setting typed in. But it will be needed for stuff like PyPlayer to get your updates, because it's going to go to whatever the falcon.com URL is. It's going to need to be able to resolve that. IPv6, that's a new IP addressing standard, and we're not going to even go there. Completely irrelevant for Christmas lights. We talk about unicast and multicast. So unicast is a standard computer networking. Computer networks and this IP addressing, it all talks in packets. So basically, a standard computer, one packet, it gets to your network switch and then is directed to that particular device. Whereas we get multicast, they're a special packet where they broadcast, in simplistic terms, to every device on your network. It can get a bit tricky because if your network equipment is not fully aware of how to deal with multicast, it can overload or overwhelm some devices. particularly like older printers and Wi-Fi access points. Good thing about multicast is though that you don't have to program any IPs in your controllers, so it works in professional stage lighting applications. They just set the DMX universe and away it goes. But I think for most people, just running unicast is going to do the trick. So home network, I'll have these slides available to download. So basically, you're going to have 192.168 something, either a 1 or a 0, and then the unique number for each device. So usually your router's like .1 or .254. So then everything else on your network's going to, the gateway and the DNS is going to point to your router's IP, being the 1.254 address, and then the last part of the IP address is going to be unique for every device on your network. So then we can have like controller 1, controller 2 as 1.201, 1.202, and so forth. Just got to keep in mind, don't create a duplicate. So we can also have separate networks to keep our controllers outside of our home network. Probably a more advanced application, but you've got to keep in mind you need to use different subnet addressing. So if your home network's 192.168.1 dot something, then you've got to make your show network something else. If you tried to use your 192.168.1 IPs on your show network as well as your home network, that routing's not going to align when we get to the next step. So because your pipe player's now got a Wi-Fi interface and a LAN interface, you can have the wired connection with the, is this got a laser pointer? No, it doesn't. The wired connection can be on the 192.168.2 dot range for all your controllers on that subnet, and your home network with the Wi-Fi can be on the 192.168.1 network. And then there's some more advanced functionality, so we can actually make it, by default, if your home computer on your home LAN, to get to another network, it's always going to go via the default gateway, which is your router. Your router's not going to then know about the pipe player. So there's a process of adding a static route, which is that command, which you can't really see on this projector screen. Then when it comes to finding IP addresses, there's various programs you can get, like Advanced IP Scanner, which you can then use to scan your local network looking for IP addresses. That's assuming that they are configured correctly. But yeah, you run that through, you can type in the range of IPs, and it'll pick up everything on the network. The other option is you can log into your router, and you can look at a section called DHCP leases, and that will show all the IPs that your router has handed out. So you can, if you get something new and you plug it in first off, you can go from there to figure out what its IP is. Some other useful commands are on that slide. So to find our computer's IP, ipconfig/all, and then when you look at the default gateway setting, if it's given via DHCP, that'll be the IP of your router from there. To find if another device is actually connected on your network is the ping command. So it's basically ping then the IP address. Probably a step 1 to make sure that your controller is actually connected to the network and has IP connectivity before you try and send DMX to it if it's not working. Then we've got commands to check DNS and routing for NS lookup and traceroute. Again, they're going to be slightly different if you're on Mac. I shouldn't have used red, should have I? Yeah, it looked great on the computer screen. Yeah, but yeah, we'll download the slides later. So Keith last year did a very good presentation on the PyPlayer networking if you wanted to have 2 subnets. So have a look at his slide if you want to get into that. If not, is anyone still awake? Any questions? Excellent, I'm done.